Today we are going to discuss composite function. So let us start. If f is a function from a to b and g is a function from b to c, then there exists a function GOF from A to C, which is defined as GOF x is equal to g fx for all x belongs to A. So point to be noted is that the codomain of f is equal to domain of g, then the composite function GOF x is defined as g of fx. So it is to remember that the function GOF exists only if range of f is a subset of domain of G. For better understanding, let us take an example. So if f is a function from R to R and g is another function from R to R, and fx is defined as x square plus 2 and gx is defined as x upon x minus 1. So find fog and GOF. Since it is quite clear that f is from R to R and g is from R to R, so the criteria for the composite function fog and GOF both are satisfied. That means the codomain of f is the same as that of the domain of G, and the codomain of G is exactly equal to the domain of f. So fog and GOF both are possible. Now first let's find fog. So fog x, which is defined as f of gx. So to find out f of gx, we need to replace x by gx in fx. So we have gx whole square plus 2, because there is fx is equal to x square plus 2, and if we replace x by gx here, so the same is substituted here. So f gx is equal to gx whole square plus 2. Now in the next step we substitute the value of gx. And what is gx? Gx is x upon x minus 1. So we substitute the value of gx here, x upon x minus 1 whole square plus 2, and now we need to simplify this. X square upon x minus 1 whole square plus 2. So x minus 1 whole square LCM, and in the numerator we get x square plus 2 x minus 1 whole square. So x square plus 2 x square minus 2x plus 1. So we have upon x minus 1 whole square is equal to x square plus 2x square minus 4x plus 2 divided by x minus 1 whole square, and ultimately we have 3x square minus 4x plus 2 upon x minus 1 whole square. So this is fog x. Now we have to find GOF. So GOF x is equal to g of fx. So to find g fx, we have to replace x by fx in gx. So as we have seen, gx is equal to x upon x minus 1. So we have to replace x by fx here. So we get fx upon fx minus 1. If we substitute x is equal to fx here in this function, we get fx upon fx minus 1. Now what is the value of fx? Fx is equal to x square plus 2. So here in this we have to substitute fx is equal to x square plus 2. So x square plus 2 upon x square plus 2 minus 1. So ultimately we have x square plus 2 upon x square plus 1. So this is GOF. So we have discussed the composite function, fog and GOF, and the necessary condition for existence of a composite function. Let us take another example. Say fx is defined as x square plus 2x minus 3 and gx is defined as 3x minus 4, and both f and g are from R to R. F is a function from R to R and g is another function from R to R, so that GOF and fog both are possible. So we need to find out fog x and GOF x. So now first fog x, which may be written as f of gx. So here in fx we need to replace x by gx, we get fgx. So we get gx whole square plus 2gx minus 3. Now we have to substitute for gx. Gx is equal to 3x minus 4. So substitute 3x minus 4 here. 3x minus 4 whole square plus 2gx. So 2 into 3x minus 4 minus 3 is equal to, expanding this bracket, we get 9x square plus 16 minus 2ab, 4 3 is 12, 12 2 is 24, 24x plus 2 3 is 6x, 2 4 is 8 minus 8 minus 3. So we get 9x square, and let us write the terms of x now. Minus 24x plus 6, so minus 18 are left, 18x, and positive 16 and negative 11. 8 minus 8 and minus 3 minus 11, plus 16 minus 11 plus 7 plus 5. So 9x square minus 18x plus 5 is fog x, and the domain and cone domain of fog is R and R. So fog is from R to R, and fog is defined as 9x square minus 18x plus 5. Now let us find GOF x. So GOF x, which may be written as g of fx. As we see, gx is equal to 3x minus 4, so if we replace x by fx in this function, we get 3fx minus 4. 3fx minus 4. Now we have to replace fx by x square plus 2 minus 3 in this. Fx is equal to x square plus 2x minus 3. So g of fx, as gx is equal to 3x minus 4, if we replace x by fx, we get 3fx minus 4, so 3fx minus 4, and now we have to substitute for fx. Fx is equal to x square plus 2x minus 3, so here we have to substitute 3x square plus 2x minus 3 minus 4. Opening the bracket, we get 3x square plus 6x minus 9 minus 4. Ultimately we get 3x square plus 6x minus 13. So here in this case, fog x is equal to 9x square minus 18x plus 5, and GOF x we get 3x square plus 6x minus 13. So GOF is also a function from R to R. Finally, f fog is a function from R to R, and fog x is equal to 9x square minus 18x plus 5, and GOF is a function from R to R defined as GOF x is equal to 3x square plus 6x minus 13.